Okay, so now we're starting a unit on congruent figures, congruent triangles. Another very, 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 very popular geometry topic is proving that triangles are congruent. So while we proved, parallel lines and angles about parallel lines in a previous unit, now we're going to be looking at proving triangles are congruent or figures that are congruent. So you have some theorems. Corresponding parts are matching parts of a figure. Here's some congruent polygons. We're mainly concerned about congruent triangles. So two triangles are congruent if and only if their corresponding parts are congruent. So we call that CPCTC. What CPCTC stands for is corresponding parts of congruent triangles are congruent. There's a third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angle is congruent. Because you can take all the angles of a triangle and add them up to be 180 degrees. Okay? So now, builders use a king post for the top of a structure. So this truss is triangle ABC is congruent to triangle ABD. And so it says list the corresponding parts. Okay, so, and we want the corresponding congruent parts. So AC is congruent to AD. And order does matter. BC is congruent. So I went from B to C, right? So that means I want to go from B to D. So going out the other direction. And then AB is congruent to itself. That is reflexive property. And then angle C is congruent to angle D. And then angle ABD is congruent to angle ABD. And then angle CAB is congruent to angle DAB. Okay. And then looking at the next example, can you conclude that triangle TRK is congruent to TUK? So by the third angles theorem, angle TKR is congruent to angle TKU. So TKR is congruent to TKU. Okay. So then we know that TK is congruent to itself by reflexive property. So now basically I have shown that all the parts are congruent. So since all parts of triangle TRK is congruent to all parts of TUK, then the triangles are congruent. Okay. Example 3, I'm going to try to show that ABC is congruent to CDA. So basically, I have some angles that are already equal, some segments that are already equal. So I have to prove that all the parts are congruent. Okay, so I would probably want to, oops, that's the wrong direction. I would probably want to extend out my parallel lines so then I can talk about my parallel lines cut by a transversal. So let's see, so statements, reasons. So one is AB is parallel to DC, and that is given. and then angle BAC is congruent to angle DCA. So BAC okay, and this is alternate interior angles. And then we could say that angle B is congruent to angle D. That is given by the third angles theorem. So angle CAD is congruent to angle ACB, third angles theorem. And then AB is congruent to DC, which is given. And then BC is congruent to AD, which is also given. So then 6 is AC is congruent to itself, and that is reflexive property. And then 7 is triangle ABC is congruent to triangle CDA by CPCTC. Okay. So now we're at the check for understanding part. If you want to go ahead and pause the video right here, and then just check and see afterwards if you got the same answer that I did. So go ahead and pause the video right now. All right, so let's see what you got. So let's see, statements, reasons. Okay, so AB is parallel to CD, and that is given. So then angle ABD is congruent to angle CBD, and angle BDA is congruent to angle DBC by alternate interior angles theorem. And then AB is perpendicular to AD, and BC is perpendicular to CD, which is given. So then angle A is congruent to angle C, because all right all right angles are congruent. And then 5 is AB is congruent to CD, and AD is congruent to CB. I was looking somewhere else. And that is, looked up for a second, I wrote the wrong thing. And that is given. And then 6, I don't know why my handwriting is so terrible tonight. BD is congruent to itself. And that is reflexive. And then triangle ABD is congruent to triangle CDB by CPCTC. Okay, and that is it for this lesson.